Well, our topic today is compound interest application involving single payment. Very similar like the previous what we discussed, compound interest single payment. Here we are using the application of that concept. So let's start and see that what we're going to cover. Long-term guaranteed income certificates. That is also the way that we invest and then we will get it at the end. Keeping your money safe when investing. So long-term promissory notes, again, we discuss these things in a short term as well, like a short-term GICs or short-term promissory notes. But here we are change the concept in order to calculate the compounding. So that definitely the investment should be more than a period. More than a one period. So saving bonds, you can personally finance Canada's debt, and strip bonds. And strip bonds are the bonds in which there is no interest. They are going to be sold at the discount price. Inflation, purchasing power, and rates of change. So these are the real life or problems or applications of the concept what we studied in unit topic number 5. The key difference between short-term and long-term GICs lies in the compounding of interest. Why do these GICs then appear in this chapter and not previously in the previous topic? The answer is threefold. One is periodic interest payments. In interest payment GICs, interest is periodically paid out throughout the term of the GIC. So in that case, the interest is paid out. So if it is interest is paid out, so then there is no possibility of a compounding. But if it is not paid out, then keep it in the account. So then it is going to be compounded. So rate used in calculating the interest account. In interest payout GICs, the posted rates appears intermixed with the posted compound interest rates. So length of the time. The term involved with the interest payments of GICs are longer than 1 year, so meeting the definition of a long-term GICs. The formula here that we want to find out the periodic interest amount, not interest rate, interest amount. How do we calculate it? I is equal to whatever we invested, which is the present value of investment, into I small or a minuscule. That's what we already discussed many times, that I is equal to IY over CY. Now here is an example, like Jackson placed 10,000 into 4 year uh, interest payout GICs earning 5.5% semi-annually interest rate. Calculate the amount of each interest payment and the interest earned throughout the term. So each payment, interest payment, so we can simply, what we can do is we just find out here what we know. We know the present value, which is 10,000. We know IY, which is 5.5%, and we also know CY is equal to 2, semi-annually compounding. So first of all, we find out the I, which is 5.5% divided by 2, so it's going to be 2.25%, right? And then 2.7, sorry, 2.75. This is in my calculation, I always made this mistake. It's 2.75%, this calculation. And our interest amount we want to calculate it, which is present value 10,000 into the I what we calculated 0.0275. So we get it like $275 each compounding period, which is semi-annually. So after 6 months. So how many payments we see here? N is equal to 4 payments for 2 years. So it's going to be 8 payments altogether. 4 years and 2 payments, right? 2 payments, 4 years. That's going to be 8 multiplied by 275. So 2,200 payment. Now, why we calculating this? We have to keep very carefully. It's a paid out. It's a paid out. So that's why we calculate it and we multiply it with the number of periods. So Andrej invested 23,500 into a 3 year variable compound interest rate, GIC. The quarterly compounding interest rate was 3.8% for the first 15 months, 3.7% for the next 12 months, and 3.65% after that. What is the maturity value of Andrej GIC? So calculate the maturity value, which is a future value, uh, uh, and variable compound rate interest rates. So we have to calculate it in a way that we find out first I for each. So do we have, yes. So there are 3 time periods. The first I is 3.8% quarterly. So we divide it with the 4. We get it 0.95%. This is the first period. The second segment of the loan is 3.75 over 4, this is percent. So we get it like 0.925%. And the third segment is 3.65% over 4. So we get it 0.9125%. N for the first is 4 into 1 into 1 by 4, which is 5. And in the second case, it is 4 into 1 is 4. And in the third case, N is equal to 4 into 3 by 4, which is 3. So 5, 4, 9, 3, 12. So these are 12. This is a 3-year, because 4 quarterly payments, 3 years of the investment. If you read the question again. 15 months, 12 months, and after that 3 years variable, right? 3 years variable. So this is what we are calculating. So we can calculate the future value 1, which is 23,500 into 1 plus 0.0095 exponential 5, right? So it's going to be 24,637.66. Now FV2 is 24,637.66 into 1 plus 0.00925 exponential 4. So by this way we get it 25,561.98, and then we can calculate future value number 3, which is 25,561 into 1 plus 0.009125 exponential 3, and finally we get it like 26,268.15. So this is the question is saying, what is the maturity value of the Andrej GIC? That's a maturity value, 26,268.15. The methods of interest-bearing promissory notes deal primarily with the sale of long-term promissory notes between organizations. So Jake, that's what we say, that it's a promissory note in which we are going to sell it to the other. So Jake Fine Jewelers sold a diamond engagement ring to a customer for 4,479.95 and established a promissory note under one of its promissory promotions on January 1st, 2014. The note requires 3% compounded semi-annually interest rate and is due on January 1st, 2017. On October 1st, 2015, Jake First Jewelers needed the money and sold the note to finance company at a discount rate of 11% quarterly. What are the proceeds of the sale? Now, proceeds of the sale, this question we have to deal with like this. If it is a normal way, if the this gonna go till the end of the contract, what will be the value? That's what we have to calculate, the future value for the whole note. And then we will find out the present value of this future value at the date of uh, at the date of selling that promissory note. So when they are selling this or discounted this promissory note on that day, we will calculate the present value, and that will be the proceeds of the interest rates are different. For the first one, when we find out the future value, the interest rate is 6%. But when we are discounting it to get the present value, the interest rate is 11%. So that's the way that it works. So let's start and doing. So for the first thing that we have to, the term, the CY is quarterly mentioned, like 6% compounded semi-annually. Sorry, it's a semi-annually. Semi-annually. So from January 1st to, it's a semi-annual payment. So what we have to do, so first of all, CY, what is CY? CY is 2 and IY is 6%. So I is equal to 3%, right? I don't need to write a formula here, right? You now become expert. Years. Now, how many years are involved? Number of years. So we know from January 1st, 2014, 2014, 2015, 2016, because January 27 is the payment. So 27 is not, 2017 is not going to be counted. So 2014, 2015, 2016, 3 years. So we can write it like 3 years. It's a semi-annual payment, right? So N is equal to 2 into 3 is going to be 6. So we want to find out the present value is given, like the jewelers are selling engagement ring with the 4,479.95. This is our present value. So if we want to find out the future value, so 4,479.95 into 1 plus 0.03 exponential 6. So that's going to be our the future value, which is 5,349.29. So keep it in mind, this is the future value if the contract. But the jeweler is selling this on October 1st, right? So what the period so if I take you back there, October 1st, 2015. October 1st, 2015. Discounted quarterly basis, right? So we started from October 1st, October, November, December, 1 quarter, and then 16 has a full 4 quarters. So these are the 5 quarters. So we see here that N is equal to 5. Now we want to find out the present value. So present value is future value, which is 5,349.29 divided by 1 plus I in this case is 11 divided by 4. So 11% divided by 4 is 2.11 2.75%. So we can write it here 0.275 exponential 5, right? So this way we get it the present value, which is 4,670.75. So this is the proceeding. The jeweler is going to get it from the financial institution from where they are discounting their right. So keep it in mind while doing these type of questions. What we have to do, we have to divide. First of all, we find out the future value of the whole promissory note, and then we want to find out the present value with the remaining period at which we are discounting the interest rate is going to be the discounted rate depending upon them. Now, saving bonds have a six key characteristics. Denominations are very clearly defined, like it can be $100, $300, $500, or a 1,000, 5,000, or a 10,000. So these are the denominations for saving bonds. Saving bonds are issued with the 10-year maturity dates and can be purchased only on these issue dates. Issuance from 1998 to 2010, saving bonds have been issued on the first of every month from November. So this is a very specific to the Canadian saving bonds issued in Canada with the serial numbers and everything. It's starting in November, and so starting in 2011, saving bonds are issued only in November and December. Calculation of interest rate, interest on saving bonds is always calculating using one of the two methods. So regular interest rates called R bonds pay the interest annually to the owner of the bonds and do not convert the interest to the principal. This is identical to an interest payment GIC. The lowest denomination available for these bonds is 6%. Compound interest rate called C bonds annually convert the interest rates from bond to the principal. This is identical to the compound interest GIC. So the bonds are available in many denominations. Saving CP Canadian price CPBs are issued. The interest rate is known for the first 3 years, and they are after announced for a period of 1 or 3 years at a time. Identification: all SBs with issues are assigned a serial letter and number, like CSBs starting with the letter S as of November 2012 were on issue number 130. This is referred to as a series S130. CPS starts with the letter P as of December 2012 were on a issue 81, so therefore refer as P81. Now, strip bonds. So there is no need to do any particular question because these are technical and serial numbers things. So strip bonds, in fact, Canada holds the record of a longer strip bonds with the 99-year terms. That's a huge long. So it means that this bond is for 2 generations, not one. The generation who's buying moves to the next generation, and then next generation is going to get the payment for that bond. Strip bonds do not earn interest. They are sold at a discount and redeemed at full value at the time of maturity. The face value of a strip bond is a maturity value payable at the end of the term. Strip bonds are traded between investors at one point in secondary financial market according to the prevailing strip bond rates at the time of sale. No minimum investment is required for strip bonds, which are available in any increment of $1. Now, this is an example of a strip bond. So these are the examples of a strip bonds. Johnson is considering purchase 5,000 face value Government of Canada strip bonds with a 23.5 year until maturity. The current market yield for these bonds is posted at 4.2031%. What is the price of the strip bond today, and how much money is gained if the bond is held until maturity? So what we can see here, let's start doing this question. So what is given here? It's a future value which is $50,000. The years or terms is 23.5 years, and IY is 4.0 2031%. CY is 2 semi-annually. So I is 4.2031 divided by 2. So we get it like 0.10155%, and N is 22 into 23.5, so 47 payments. Now, if we want to find out the present value of this, so this 50,000 divided by 1 plus 0.0210155 exponential 47. So we get it like 18,812.66. So I, what we are looking for, along with the total interest. So the total interest is 50,000 minus 18,812.66. So it's a 31,187.34. That's the money they're going to get it. The second is Cameron invested in of 97,450 face value government of British Columbia strip bonds with a 25 years maturity. Market yield at that time was 9.1162%. 10.5 years later, Cameron needed the money, so he sold the bond with the current yield were this much. Calculate the actual yield and gain the Cameron realized on his investment. Calculate the nominal interest rate IOI that Cameron realized while in possession of the strip bonds. Also calculate the total gain. So what we have to do first, I is 9.1162% divided by 2. So we get it like here 4.5581%, and n we find out 2 into 25, so it's going to be 50. So write the future value is 97,450. Present value we want to calculate it, so 1 plus 0.045581 exponential 50. So if you solve it, you get it like a present value is equal to 10,490.95. This if the term is completed. But when we discount it, I is 10 point, this is CY 10.0758 divided by 2, we get it 5.0379%, and n is equal to 2 into 14.5, which is 29. So if we want to calculate the present value, so 97,450 divided by 1 plus 0.050379 exponential 29. So we get it 23,428.63. So calculate the actual yield and gain the Cameron realized. So we find it out the 10.5 years later, Cameron needed the money, so he sold when the current yield was it. That's what we want. So this is our present value. This is our future value. This is our present value, right? And then what we can find out the I. So I is future value, which is 23,488.53 divided by 63, sorry, 63, this is 63, divided by 10,492.95 exponential 1 by n, which is n is 21 remaining period, so -1. minus 1, right? The formula is saying that minus 1, if you remember the formula. So we get it like 0.038991, and as IY is 2, so we divide this with 2, or you multiply with this 2, so IY is equal to 0.038991 into 2, so we get it like 7.7982%. And then the whole amount, you can subtract this value from this and you can get it. So this is the way that we can. The last topic in this chapter is inflation, purchasing power, and rate of growth. So we can calculate this purchasing power of a dollar, PPD, is equal to $1 divided by 1 plus I exponential n into 100. So this is the way that we can calculate the purchasing power. So the last two questions for this topic. Many experts today claim that the average Canadian retiree in 2012 needs approximately 40,000 in gross annual income to retire comfortably. Assume that you are 20 years old in 2012. Historically, in Canada, the inflation rate has averaged 3.16%. If the average inflation rate continues in the future, what gross income will you require when you retire at the age of 65? So what we can do here, it's very simple. Like I is, so if you look at it here, 3.16, the inflation rate is 3.16, 3.16%. N is equal to 45, because 65 minus 20 is 45 years. So what will be the future value? 40,000 is the present value, plus 1 plus 0.0316 exponential 45. So is going to be 162,207.15. That should be the amount of. The historical inflation rate in Canada were 3.13% from June 2007 to June 2008, minus 2.6% from June 2008 to 2009, and 0.69% from June to comparing June to 2010. What is the purchasing power of 2010 in terms of dollars? So the best way to do is that I is 3.13%, and then I is minus 0.26%, and then I is 0.96%. N1, N2, N3 is 1 year, right? So we don't need to worry about N1. This is I1, I2, I3. N1 is 1, N2 is 1, and N3 is 1. So if we want to find out PPD, which is $1 divided by 1 plus 0.0313 into 1 plus point, but here the catch here, it is like it should be minus like 1 minus 0.0026 into 1 plus 0.0096. So if we calculate it by this way into 100, we have to multiply with 100. So we get it like 96.2933%. So the purchasing power of a June $2,000 in June 2010 is 96.2933%. If a 100 in June 2000 could purchase 100 items in June 2000, and 700 could only purchase about 96 items in 2010. So that's the way it works. So by this way, we cover this compound interest. single payment application. So we learn here the application. So uh, stay tuned. One more topic we're going to cover it, and then we